In my last tutorial entitled High Availability Pi-Hole and Local DNS, we saw how to make two Pi-holes replicate each other with orbital sync, and we also installed Nebula Sync for when Pi-hole version 6.0 is released. We then used the virtual router redundancy protocol to configure the two Pi-holes for high availability automatic failover. Local DNS is very powerful in the Homelab. Welcome back to the Scotti-BYTE channel, and this is Scott. Today, we're going to install Pi-hole on my Raspberry Pi 4 and add it to the orbital sync configuration that we created in the last video. I will then add the Pi-hole to the VRRP configuration. If you've been watching my channel for a while now, you know that we create Homelab self-hosted services with subdomains that are assigned via your DNS service provider. And when we do so, they're named according to your domain name. So as a good example, my Rocket chat, which is at chat.scotti-byte.com, is a subdomain of scotti-byte.com. However, when I use local DNS, I make things a lot simpler, and I just have my various server instances, Incus containers, LXD containers, virtual machines, and bare metal machines simply addressable with a direct DNS name. So I don't have anything like a local DNS subdomain. All I have is a straight up name. And to emphasize that, I can just do something like an SSH over to Pi-hole, as in the last video, and we connect over to Pi-hole. Likewise, if I do an SSH over to Rocket Chat, it connects directly over to the instance that is running Rocket Chat. So one of the things that you'll find is that local DNS is extremely handy because, of course, we don't have to remember all of the IP addresses for everything that you are connecting to. Few people realize that these DNS names actually have some explicit terminology attached to them. For example, when I did the SSH over to Rocket Chat, really implicitly it meant Rocket Chat dot, and you'll see that that's able to connect over to that just as well. So in the Linux world, if we don't have something like an SSH over to Rocket Chat .local, we don't have to put the dot at the end, and neither do we if we just go ahead and do an SSH over to Rocket Chat. However, in the Windows world, and here we're at a Windows 11 desktop, if I do an SSH over to Rocket Chat, it won't actually connect because it will be unable to resolve that DNS name. In the Windows world, if it had been rocketchat.local, we would have been able to connect to it. But since I just have my name, Rocket Chat, I have to explicitly put the period at the end of the DNS name. And when I do that, it is able to connect over to that Rocket Chat instance correctly. This is just something that you need to know when you're using local DNS in your Homelab and all you want to use are simple DNS names. Also in Windows 11, it's noteworthy to point out that if we do an ipconfig /all, and we look here at our DNS servers, the DNS server address from the last video was 172.16.0.10, which is our VRRP, or Virtual Router Redundancy Protocol address. And that's because that address is entered into our configuration for our DHCP server on the router. One of the things that I did not mention last time is that my primary Pi-hole is running on my Inca server named VMS Mist, and my backup Pi-hole is running on a different piece of hardware, which is my Incus server named VMS Rain. And having your redundant Pi-holes on two different pieces of hardware provides the failover redundancy that we want to see. So in this particular video, what I want to do is I want to connect over to a Raspberry Pi 4 that I have, and it has the simple DNS name of Pi 4. And on this Pi 4, we want to go ahead and install Pi-hole. I believe the easiest way to install Pi-hole on a dedicated piece of hardware is to simply run the Pi-hole installation script, and that's what this is, where I do the curl command over to this script that is located on the Pi-hole site. So I just go ahead and hit enter, and it asks for my sudo password, and I hit enter again, and it says that it is in the process of installing Pi-hole. And of course, while in the process of installing Pi-hole on anything, a virtual machine, an Incus container, a LXD container, or a physical machine, bare metal machine, as we're doing here, it's very important to have a static address for the machine running the Pi-hole. And it comes up with this informational message telling us that. And then it wants to choose an interface in order to run the Pi-hole. And of course, we're going to use the wired interface of this particular Raspberry Pi. And although the Raspberry Pi is running Docker, I'm just going to run this thing physically on the ETH0 interface. And then it says, as a reminder, here's your address and here's your gateway. The gateway is the address of the router. And so I'll go ahead and say, yes, I currently have a static address, and that is the correct information. So I go ahead and hit that and then say OK. And then it asks me which DNS provider I want to use for upstream translation. My personal preference is Cloudflare. And so once I've done that, I can go ahead and do an OK. And then it says it's going to use the third-party block list in order to block ads. Yes, that's fine. And do you want to use the admin web interface? Well, my feeling is if you don't have a web interface for Pi-hole, you can't go in and examine anything, but I'll go ahead and say yes. And it says the same thing. Do you want to install the necessary modules for that web interface? Yes, I do. And would you like to enable query logging? Absolutely. We want to see which things it blocks. And yes, we want to show everything in the logs. So after we've answered those questions, it goes on and completes the installation of Pi-hole. At the end of the configuration, they'll provide you a random password for your admin interface for the Pi-hole, and that's for the web interface login for Pi-hole. But I usually like to go ahead and change that, and I'll do a Pi-hole space -A space -P. And then it'll go ahead and ask you for a password, and I'll go ahead and add the password that I use for my Pi-holes. And then it will have changed it to that password. Now that the Pi-hole installation has completed, I log into it via the web page, which is the address of the Pi-hole /admin. And you'll notice that it has no current queries that have been discovered. no current queries that have been blocked, and so on. And the reason for that is because currently we don't have any clients pointing to this particular Pi-hole. And if we click on clients, we're really not going to see anything here. If we go down to local DNS, likewise, we don't have any DNS records. In order to fix this, we want to leverage what we learned in the high availability Pi-hole and local DNS video. And so the thing we want to do is head back down to the terminal, but we're not going to need the Pi-hole login anymore. We're going to exit out of it, and we're going to go ahead and SSH over to our Nebula sync. And as a reminder, Nebula Sync is the actual program that we're going to be using in version 6.0 of Pi-hole. If we do an ls over here, although we configured Nebula Sync, we did not start Nebula Sync. So in the interim, while we're running Pi-hole version 5.1.8 or 5.18 actually, we're going to be using Orbital Sync for our replication. So let's cd into the Orbital Sync directory, and let's configure the configuration file for Orbital Sync. So now we're going to go ahead and do a nano on compose.yml and come up here, and we're going to make a copy of this secondary host base URL and secondary host password, and I'll go ahead and copy that. And since Nano is not a screen-oriented editor, I have to come back down here and move where I want to put that, and I do a Shift-Control-V, which copies that in there. I'll go ahead and delete this blank line. And recall that the address of our Pi-hole is 172.16.1.86, and this is going to be the secondary host number 2 for both the base URL and the base password. So don't forget to change both the address and also the name of the parameter. Once I've edited everything sufficiently, I do a Control-O and Enter to write the file out, and a Control-X to exit the Nano editor. In order to allow the new configuration to replicate the primary Pi-hole to the backup Pi-hole and also to the Raspberry Pi 4, we're going to do a Docker compose up-d, and I'm going to do an ampersand Docker compose logs -f so I can follow that replication process and make sure that it's working. And at this point, you can see that all the replications have been successful, and now it's waiting 15 minutes to perform the next replication. I can now do a Control-C to get out of the Docker compose logs command, and if I do a Docker ps, you'll notice that Orbital Sync is still running. Let's go ahead and head on up to the Pi-hole interface here, and if we go ahead and go up to the dashboard and then back down to local DNS and click on DNS records, sure enough, you can see that my DNS records are being entered in here correctly. And if I look at my CNAME records, the same thing is true. We have all of our CNAME records also being replicated to the new Pi-hole installation on the Raspberry Pi 4. From my tutorial entitled High Availability Pi-hole and Local DNS, we know that this Pi-hole is not yet participating in our list of Pi-holes, and that is because we need to configure Virtual Router Redundancy Protocol. So let's go ahead and head on down to the terminal once again. And this time we're going to log off of the system that is running Orbital Sync, and we want to sign back on to the Pi 4 because the Pi 4 is where we're going to want to configure our VRRP protocol. So just like in the previous video, we're going to go ahead and do a sudo apt install on keepalive-d. I enter my password and I say, yes, I want to go ahead and install keepalive-d. Once keepalive-d is installed, we want to go ahead and edit the configuration file, or I should say create the configuration file, because we do not yet have a configuration file as a result of installing keepalive-d. So let's go ahead and do a sudo nano /etc/keepalive-d, keepalive-d.conf. When we get into the nano editor, we want to go ahead and configure our keepalive-d configuration file, and this will be in the show notes. But basically we do exactly what we did in the last video. The difference is here that the primary Pi-hole was running at priority 255 as the master. The backup Pi-hole was running as priority 254, and this Pi-hole running on the Raspberry Pi 4 will have a priority of 253. And once again, it's very important that we have the same virtual router ID. This, of course, is the second of our backup nodes. The first backup node was the Pi-hole backup, and now we have the Raspberry Pi as the second backup. And then the virtual IP address for our VRRP is the same at 172.16.0.10, and I use a /16 because of my network. Your virtual IP address, if it's more typical, is going to be something more like 192.168.1. something, and your subnet mask would be /24. Let's go ahead and do a Control-O and Enter to write the file out, and a Control-X to exit the nano editor. At this point, in order to get that configuration file to take effect, we need to be able to restart the keepalive-d service with a sudo systemctl restart keepalive-d. And then if we want to prove that it is up and running, we'll go ahead and do a sudo systemctl status keepalive-d, and we should be able to see that our keepalive-d service is up and running. At this point, I can go ahead and do a Control-Z to exit out of the status command, and we now have 3 nodes participating in our VRRP for our Pi-hole, which basically means that I can have my primary Incus container for Pi-hole main go down. I can have my backup container for Pi-hole backup go down. If both those Pi-holes happen to fail, then the Raspberry Pi 4 here running Pi-hole will go ahead and take over and do my DNS lookups. So let's test this out, and I'll do so by exiting out of my Raspberry Pi 4 completely here and going back to my desktop system. At this point, all 3 Pi-holes are up and running. Let's go ahead and stop the primary Pi-hole with an Incus stop, and it's running over on VMS Mist, so VMS Mist :Pi-hole main, and that will go ahead and stop the primary Pi-hole. Let's go ahead and also stop the backup Pi-hole, and we'll do that with an Inca stop VMS rain, which that's running over on a different Inca server, colon Pi-Hole backup. Now that both of the Pi-holes are shut down, let's go ahead and see if we can do a ping on the Rocket Chat. And if it works, that means that the DNS translation is being performed by the Raspberry Pi 4. And sure enough, it's able to translate our DNS records, indicating that our tertiary Pi-hole that's running on the Raspberry Pi 4 has taken over the operation. Just as a review from last time, Nebula Sync has replaced Gravity Sync to replicate our Pi-hole local DNS A records and CNAME records once Pi-hole version 6.0 is released. And we covered that last time in my video entitled High Availability Pi-hole and Local DNS. So if you've not seen that, you're going to want to go ahead and go back and review that if there seem to be some missing pieces in this particular presentation. And again, we used Orbital Sync to handle our replication while we're still running Pi-hole version 5.x. And we used Virtual Router Redundancy Protocol to define a virtual address across all of our Pi-holes. And in this video, we added a Raspberry Pi as a tertiary Pi-hole in order to be able to do our DNS translation in the event that my primary and my backup Pi-holes both go down. And if your master Pi-hole is inaccessible, local DNS would be automatically handled by the next available Pi-hole as defined by VRRP, and as we just demonstrated by shutting down both of the Incus containers that were running the primary and the backup Pi-holes. And Virtual Router Redundancy Protocol is useful to provide high availability access to servers where you've replicated the required applications and data. And so, just once again to point out, this is only one possible use for VRRP. You might be able to come up with others. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.